In this video, let us explore the D flip-flop, a fundamental component in digital logic circuits. This presentation will cover its definition, truth table, circuit diagram, timing diagram, key characteristics, and applications. So let's dive into the world of the D flip-flop, also known as the data flip-flop, and discover its role in data storage in various digital systems. A D flip-flop, short for data flip-flop, is a sequential logic circuit. Its primary function is to store a single bit of data. The key feature of the D flip-flop is that it transfers the input to the output at a specific point in time, triggered by a clock edge. In essence, it captures the value present at its input when the clock signal transitions, holding that value until the next relevant clock edge. The truth table illustrates the behavior of the D flip-flop. The table consists of 4 columns labeled as D CLK, Q of n plus 1, and Q prime of n plus 1. When the D input is 0 and the clock input transitions from low to high, which is represented by an upward arrow, the output Q of n plus 1 becomes 0 and Q prime of n plus 1 becomes 1. Similarly, when D is 1 and the clock transitions from low to high, Q of n plus 1 becomes 1 and Q prime of n plus 1 becomes 0. When the clock is 0 irrespective of the value of D, the output Q of n plus 1 retains its previous state, Q of n, and Q prime of n plus 1 remains Q prime of n. Note that an upward arrow symbolizes a positive edge trigger and X indicates don't care, meaning the output is independent of the input value in that particular case. Here is the circuit diagram of a D flip-flop constructed using NAND gates. The circuit consists of 4 NAND gates and 1 NOT gate. The input D is directly fed into one of the NAND gates, and also passed through a NOT gate before being fed into another NAND gate. The clock input is connected to both NAND gates. The outputs of these NAND gates are then fed into another set of cross-coupled NAND gates, which form an SR latch. This latch generates the final outputs Q and Q prime, representing the stored data bit and its complement. The connections between these gates ensure that the output Q follows the input D when the clock signal is active. The timing diagram illustrates the behavior of the D flip-flop over time. The diagram consists of 4 signals: the clock, the D input, the Q output, and the Q prime output. The clock signal transitions between high and low levels. The D input changes its state at various times. The Q output changes its state only at the rising edge of the clock signal, taking on the value of the D input at that time. The Q prime output is always the complement of the Q output. The vertical lines marked as T1, T2, and so on indicate the time intervals. The small arrows on the clock signal indicate the positive edge where the D flip-flop updates its output. The D flip-flop has several key features. First, it is edge-triggered, meaning that the output changes only at the rising or falling edge of the clock signal. Second, it has a single data input, D, which is directly transferred to the output. Third, it offers transparent data transfer, where the output Q follows the input D when the clock is active. Fourth, it does not have any race conditions or invalid states, ensuring reliable operation. Fifth, it provides complementary outputs Q and Q prime. These features lead to several advantages. It has a simple design and is easy to implement. It is a reliable data storage element. It does not have any feedback complexity issues. It provides synchronous operation with the clock. And finally, it serves as a fundamental building block for more complex circuits. The D flip-flop is used for data storage, serving as memory elements in registers and storage systems. It is also used in shift registers for serial data transfer and processing. In counters, it acts as the foundation for frequency dividers in counting circuits. Finally, it is used to create timing delays in digital systems. To summarize, the D flip-flop is an edge-triggered sequential circuit, has single input data transfer, has no race conditions or invalid states, and forms the foundation for memory systems. The D flip-flop is an essential building block for digital storage and sequential logic design. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.